Okay, welcome to this Excel tip. For this tip, we are going to cover data tables. So data tables in Excel are extremely useful, and I'm going to show you one example of their usefulness. So let's look at this Excel sheet that I just made, and it has some assumptions over here, and it has some calculations over here. The big goal of this Excel sheet is that highlighted in blue. Basically, I want to know if I replace an incandescent bulb in my house with an LED bulb, how long is it going to take the electricity savings from that LED bulb to pay back for the initial upfront cost of that LED? So that's what this whole sheet does. So right now, with all the assumptions I have, it's going to take 0.31 years. So that's pretty good. So let me show you another thing. The nice thing about Excel is because all of this is calculated with references, is I could go to this hours per day, and I could say, okay, well, yeah, this bulb's used 15 hours a day, so that's a lot. If I only use the bulb for 3 hours a day, then my simple payback jumps up to 1.53. If I only use the bulb for 1 hour a day, then it jumps up to 4.6 years. So that's pretty sizable difference. Now, let's go back to the original 15, and I could do the same thing with the cost of electricity. So let's say the cost of electricity was, instead of 10 cents, 5 cents. Then it changes my simple payback. And instead of 5 cents, or 10, let's say it's 15 cents. So you can see all of these things make a change in the simple payback. And that's one really nice thing about Excel, is that you can see these changes right away when you make them. However, what if I wanted to make these change? What if I wanted to see a sort of chart or a table or even a graph of how these changes affect the simple payback? That's where Excel comes in really handy. And if we go to data, the what if analysis, and the data table. So basically, it's what if is exactly what it says. What if I change this cell? What happens to that cell? That's what I'm looking for. Okay, so I'm going to first start out with the time used in hours per day down here. And I'm just going to say 1, 2, 3. And I'm going to go all the way up to, well, let's just go up to 24. So let's wait until, okay, so 24. So that's good. So now I have that time used as hours a day. And actually, I think I'm going to go up by 2 instead. Just so that way it's a little bit smaller, a little more condensed, and we'll just go up to 23 hours a day. Okay, so we have the time used in hours per day. And actually, I'm going to make this go up here. And then we're going to have the simple payback here. And how what if data table works is the first thing we need to do is we need to make this be a cell reference to our original data value. So basically all that's saying is that this has to reference what our objective value is. Okay, so this is just equals I5 there. Okay, then what we're going to do is select all of this and click on what if data table. Now, the row input cell in this case is going to be blank because we're not having anything on this way. I'm going to show you next how to do the row input here. The column input cell, basically what that means is what value are we putting in for time used? And that's this. So basically what it says is I'm going to replace this 15 with a 1 and see what this cell becomes. Okay, so if we replace this with a 1, this cell becomes the 4.6, right? If we replace it with, let's say, 21, this becomes the 0.22 down here, right here. Okay, so all I just did was say, okay, it's basically what if. What if I replaced cell B2 with the value of 1 what would cell I5 become? So that's what I've done with that simple data table. So now let's go ahead. I'm going to copy and paste this just to make it a little easier for myself. Let's just make it a little cleaner. Okay. So now, what if instead the simple payback is going to be in here, but what if I also want to not only do the time used, but also per day, but also the cost of electricity. So here, maybe I want the cost of electricity as 1 cent, and again, we'll just go up by 2-cent increments. So that's fine. We'll go up to 19 cents, and we'll make it dollar signs just so that way it's pleasing. Okay. So now what we do is our objective cell is in this corner. This is called a 2-variable data table. And what we're going to do is when we drag this over, what we're going to do now is we're going to do that what if analysis. But our row input cell is going to be the cost of electricity, and our column input cell is going to be the hours per day. So now we get a full range of simple payback. So let me show you how this works. So if we put in the cost of electricity of 1 cent and the hours per day of 1, then this is what this cell equals. We could do this for any of these values that we wanted to. The other really cool thing I love about doing this stuff, and we're going to copy and paste this as values for a second. Just so that way we can get rid of that, is you can make an area chart. So let's go to insert. It's in here. So this doesn't give us too much useful information except in the very bottom here. Basically what it's saying is that for many of the scenarios that we used, the simple payback is ridiculously low, 0 to 10 years. And then only at these really, really sort of really low hours per day used and really low electricity costs is the simple payback more than 10, between 10 and 20, 20 and 30, 30 and 40, 40 and 50. So you could redo this plot a couple different ways, but this is just to give you an idea of the way you can use area charts to see this result, or contour charts, I believe this is called. So let's just move this down here. And hopefully you can see the power of data tables here. But when you think of a data table, just think of basically what if. What if I change this? What does this become? Or what if I change these two things? What does this become? All right, that's it for this tip. Thanks for watching.